And now in this lecture we'll find out the area of the green shape. In the drawing we have two squares. We have the big square TSQP and the small square ABCP. We also know that the area of this triangle AMP equals to 9 square units in its size, and the area of this quadrilateral MBCP is equal to 27 square units in its size, and our task is to find out the area of this green shape. So first of all, we know that the area of any square equals to the length of one side squared. And again, the area of any square equals to the area of one side of the square squared. That is to say the area of the small square ABCP will be equal to AP squared. And the area of square ABCP in total equals to 9 plus 27, that is 46 square units in its size. So the area of square ABCP in total it is equals to 9 plus 27. 9 plus 27 is 36 square units in its size. So, and you also know that the area of any square equals to the length of one side squared. And therefore, the area of this square ABCP will be equal to AP squared. So AP squared equals to 36 square units. That is the area of this square ABCP. So here we take a look out of this equation, and here that the length of side AP is equal to the square root of 36, that is 6. So side AP of square ABCP is equal to 6 units in its size. We know that all the angles inside any square are right angles, and therefore in square ABCP this is a right angle, and therefore triangle MAP is a right angle. And the area of the right angle AMP is equals to 9 square units in its size. And we know that the area of any triangle is equal to the base of the triangle times the height of the base over 2. So the area of the right triangle AMP is equal to the base of the triangle. We take the base SAP times the height AM. AM is the height because it creates 90 degrees with the base. So times AM over 2. Okay. And then again, the area of this triangle AMP equals to the base of triangle AMP, that is AP, times the height AM over 2. And it is given us the question that the area of triangle AMP equals to 9 square units. So we write down that the area is 9 square units. AP is 6, so we substitute AP by 6, and we get that 6 over 2 times AM equals to 9. 6 over 2 is 3, so in this side of the equation we have 3 AM equals to 9. And 6 over 2 is 3, so this side of the equation we have 3 times AM equals to 9. Here we divide this equation by 3 and find out that the missing sign AM equals to 9 over 3, that is 3. AM equals to 3 units in its length. This is side AM. This equals to 3 units in its length. Here we will implement the Pythagoras theorem on this right triangle, triangle APM. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I copy the right triangle APM in a new page and we'll implement on this right triangle the Pythagoras theorem. Only the hypotenuse BM is missing. Know that side AM equals to 3 and side AB equals to 6 units in its length. We find out the length of the hypotenuse BM by implementing the Pythagoras theorem on this right triangle, triangle AMP. Here by PT's evaluation for Pythagoras theorem. So actually, this is the right triangle AMP, this is a copy from the original drawing. In this right triangle AMP, according to the Pythagoras theorem, MP squared, that is the square of the hypotenuse, is equal to AM squared plus AP squared. MP is the missing side, so we need to see this, so it is MP squared equals to AM squared. AM is 3, therefore AM squared is 3 squared, that is 9, plus AP squared. AP is 6, therefore AP squared is 6 squared, that is 36. So in total, MP squared equals to 9 plus 36, that is 45. MP squared equals to 45. Here we'll substitute 45 by 9 times 5, and we get that MP squared equals to 9 times 5. Here we take a root out of this equation, and we get that the missing hypotenuse MP is equal to the square root of 9 times 5. The square root of 9 is 3, so inside the root will have to only be 5. So in total we found out that the length of the hypotenuse MP is equal to 3 times square root of 5 units in its length. This is the hypotenuse MP. This equals to 3 times square root of 5 units in its length. We know that all the angles inside square TCQP are right angles, and therefore this is a right angle. Those two angles are defined as vertex angles, and we know that vertex angles are equal to each other. So those two angles are equal to each other. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha, because they are equal to each other according to the rule that vertex angles are equal to each other. So in the small right triangle TMB, this angle equals to 90 degrees, this angle equals to alpha, and therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Likewise, in the right triangle AMP, this angle equals to alpha. This angle equals to 90 degrees. And therefore this third missing angle must be equal to 90 degrees minus alpha, according to the sum rule that says that the sum of the angles in a triangle is equal to 180 degrees. It is very easy to see that the small right triangle TMB is similar to this big right triangle MAP according to angle similarity rule. I'll explain anyway why those two right triangles are similar to each other. First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. So if you found out that all the angles in the right triangle, small right triangle DMB are corresponding equal to all the angles in the right big triangle AMP, and therefore those two right triangles are similar to each other according to angle similarity rule. So if you found out that the big right triangle AMP is similar, this is the sign of similar to the small right triangle TMB according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AM of the big right triangle AMP over side CM of the small right triangle TMB equals to side AP of the big right triangle AMP over side TB of the small right triangle TMB. And it is also equals to side MP of the big right triangle AMP over side MB of the small right triangle TMB. Repeat again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side AM of the big right triangle AMP over side TM of the small right triangle TMB equals to side AP of the big right triangle AMP over side TB of the small right triangle TMB, and it is also equals to side MP of the big right triangle AMP over side MB of the small right triangle TMB. AM equals to 3 over TM. TM is the missing side, so leave it as it is. And it is equals to AP. AP equals to 6 over TB. TB is the missing side, so leave it as it is. And it is equals to MP. MP equals to 3 times square of 5 units in its length over MB. What is the length of side MB? Actually, we know that one side of square ABCP, this square ABCP is equal to 6. And you know that all the sides of a square are equal to each other. Therefore, AB is also equal to 6. So AB minus AM equals to MB. Write it down. AB minus AM equals to MB. So MB equals to AB 6 because of the fact that all the sides of a square are equal to each other, minus AM. AM equals to 3 units in its length. 6 minus 3 is 3. So if you found out that MB equals to 3 units in its length, MB equals to 3 units in its length. MB is 3. So in total, you actually found out that 3 over Tm equals to 6 over Tb equals to square root of 5, 3 times square root of 5 over 3. We have 3 in the numerator, 3 in the denominator, so 3 will get cancelled, and we left only with square root of 5. So in total, we found out that 3 over Tm equals to square root of 5. But again, if you found out that 3 over Tm equals to the square root of 5. Here we multiply this equation by Tm, and then we divide it by square root of 5, and we get that the missing side Tm equals to 3 over square root of 5 units in its length. This is the missing side Tm. This is equals to 3 over square root of 5 units in its length. From this long equation, those two expressions are equal to each other. That is to say, 6 over Tb equals to the square root of 5. And again, those two expressions are equal to each other. That is to say, 6 over Tb equals to the square root of 5. Here we multiply this equation by Tb, and then we'll divide it by square root of 5 simultaneously, and get that the missing side Tb is equal to 6 over square root of 5 units in its length. So here, this is the missing side Tb. This equals to 6 over square root of 5 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? From the drawing, it is very easy to see that the area of the green shape in total equals to the area of the big square TSQP. The area of the big square TSQP minus the area of this quadrilateral MBCP, that is 27, minus the area of this small right triangle TBM. Repeat again. The area of the green shape in total equals to the area of the big square TSQP minus the area of this quadrilateral MBCP, that is equals to 27 square units in size, minus the area of this small right triangle TMB. So I write it down. We actually found out that the area of this green shape, that is the area that we are looking for in this question, is equals to the area of the big square TSQP minus the area of this quadrilateral MBPC, that is equal to 27 square units in its size. minus the area of this small right triangle, TBM. Repeat again. The area of this green shape in total equals to the area of the big square TSQP minus the area of quadrilateral MBPC minus the area of the small right triangle TBM. The area of any square equals to the length of one side squared. The length of one side squared. So the area of this square TSQP will be equal to the length of TP squared. So it is TP squared minus the area of this quadrilateral MBCP is given as the question that the area of this quadrilateral MBCP is equal to 27 square units in its size. It is minus 27 minus the area of this small right triangle TBM. The area of any triangle equals to the base of the triangle times the height of the base over 2. We choose the base as TB. Therefore, the height will be Tm because it creates 90 degrees with the base over 2. So in total, we found out that the area of this small right triangle TBM equals to the base TB times the height of the base Tm over 2. What is the length of TP? TP in total equals to Tm plus MP. So it is Tm plus MP squared minus 27 minus the area of this right small triangle TMB. This equals to TB. TB is square 6 over square root of 5 times the height Tm, that is 3 over square root of 5 divided by 2. Okay, again, if you found out that the area of the green shape equals to Tm plus Mp squared, that is actually Tp squared, minus the area of quadrilateral MBPC, that according to what is given in the question is equals to 27 square units in its size, minus the area of the small right triangle TBM, that is equals to the base, that is 6 over square root of 5 times the height of the base, that is 3 over square root of 5 divided by 2. Tm equals to 3 over square root of 5. See it here? Plus Mp. Mp equals to 3 times square root of 5 squared minus 27. And here we have 6 times 3 is 18, and 18 over 2 is 9, so the amount over here is 9, and square root of 5 times square root of 5 is 5. So in total, this expression equals to 9/5. We have here 3 over square root of 5 plus 3 times square root of 5. So here we will multiply 3 times square root of 5 by square root of 5, and then we divide it by square root of 5 in order to have a common factor with this number. And you get that in total we have here the number of square root of 5 In the other we have 3, and here we actually divided this number by square root of 5 and then multiplied by square root of 5. So here we have square root of 5 times square root of 5 is 5, and 5 times 3 is 15. So in total, this expression is equal to 15 after we divided by square root of 5 and then we multiplied by square root of 5. So we have 3 plus 15 over square root of 5 squared minus 27, and minus 9/5 is 1.8. Again, 9/5 is 1.8, so here we have minus 1.8. 3 plus 15 is 18. We have 18 over square root of 5 squared minus 27 minus 1.8. 18 squared is 324 over square root of 5 squared. Square root of 5 squared is 5 minus 27 minus 1.8. 324 over 5 324 over 5 is 64.8. 64.8 minus 27 minus 1.8. So in total, we found out that the area of the green shape equals to 64.8 minus 1.8 minus 27. 64.8 minus 1.8 is 63, and 63 minus 27 is 36. So in total, we found out that the area that we are looking for in this question, that is the area of this green shape, is equal to 36 square units in size. The area of the green shape in total equals to 36 square units in size. The area of this green shape equals to 36 square units in size. So in the next step, I will summarize the lecture. Our task in this lecture is to find out the area of this green shape. So in the drawing, we have two squares. We have the big square TSQP and the small square ABCP. In addition, you know that the area of this quadrilateral MBCP is equal to 27 square units in its size, and the area of this triangle MAP is equal to 9 square units in its size. Again, our task is to find out the area of this green shape. So first of all, we know that the area of any square equals to the length of one side squared. Again, the area of any square equals to the length of one side squared. Therefore, the area of this square ABCP will be equal to AP squared, the length of AP squared. But we know it is given us the question that the area of this square ABCP in total equals to 9 plus 27, that is 36. So we can write down that AP squared, that is the area of this square ABCP, equals to 36 square meters in size. And again, the area of the square ABCP in total equals to 9 plus 27, that is 36. So we can write down that the area of square ABCP, that is actually the length of one side squared, that is to say AP squared, equals to 36 square meters according to what is given to the question. Here we took a root out of this equation and found out that AP equals to the square root of 36. So the length of side AP is 6 units. We know that all the angles inside the square are right angles. So in square ABCP, this is a right angle. Therefore, triangle AMP is a right angle because this angle equals to 90 degrees. So in the next step, we calculated the area of this right triangle AMP. Note that the area of any triangle equals to the base of the triangle times the height of the base over 2. Therefore, the area of this triangle AMP must be equal to the base of the triangle, that is AP, times the height of the base AM over 2. And again, the area of this triangle AMP, the right triangle AMP, in total equals to the base, that is AP, times the height to the base, that is AM over 2. AP is 6, times AM is the missing side, so we leave this, it is over 2. But it is given as a question that the area of this right triangle AMP is equal to 9 square units. So we can substitute the area by 9. The area equals to 9. Again, AP is 6, AM is the missing side, then we have to divide it by 2. So in total, we found out that 6 over 2 times AM equals to 9. That is the area of this triangle AMP, the right triangle AMP. 6 over 2 is 3, so 3 AM equals to 9. Here we divided this equation by 3 and found out that the missing side AM, this is the missing side AM, that equals to 3 units in its length. In the next step, we implemented the Pythagoras theorem on this right triangle AMP. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I copied this right triangle AMP in a new page, and we implemented the Pythagoras theorem on this right triangle AMP. This is the right triangle AMP, according to the original theorem. In this right triangle AMP, according to the Pythagoras theorem, MP squared, that is the square of the hypotenuse, equals to MA squared plus AP squared. Again, MP squared, that is the square of the hypotenuse, equals to AM squared plus AP squared. MP is the missing side of electricity, so it is MP squared equals to AM squared. AM is 3, therefore AM squared is 3 squared, that is 9, plus AP squared. AP is 6, therefore AP squared is 6 squared, that is 36. So in total, we found out that MP squared equals to 9 plus 36 is 45. MP squared equals to 45. Here we substituted 45 by 9 times 5. And we found out that MP squared equals to 9 times 5. Here we took out all this equation and finally found out that MP equals to the square root of 9 times 5. The square root of 9 is 3, so inside the root we left only be 5. In total, we found out that the length of the hypotenuse MP is equal to 3 times square root of 5 units. This is the hypotenuse MP of the right triangle AMP. This is equal to 3 times square root of 5 units in its length. Those two angles are defined as vertex angles, and you know that vertex angles are equal to each other. So if we define this angle as alpha, then this angle must also equal to alpha because they are equal to each other according to the rule that I mentioned. So in this small right triangle TM, first of all, we know that all the angles inside square TSQP are right angles, and therefore this is a right angle. It is 1 out of 4 angles of square TCQP, and therefore it is a right angle. So The small right triangle TBM, this angle equals to 90 degrees, this angle equals to alpha, and therefore this missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in the triangle. Likewise, in the big right triangle AMP, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. According to the sum rule, that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we prove that those two right triangles are similar to each other according to angle similarity rule. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, both those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So if we found out that all the figures of the big right triangle AMP are corresponding equal to all the figures of this small right triangle TMB, therefore those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We derive the side AM of the big right triangle AMP over side TM of the small right triangle TMB is equals to side AP of the big right triangle AMP over side TB of the small right triangle TMB, and it is equals to side MP of the big right triangle AMP over side MB of the small right triangle TMB. And again, we will derive the side AM of the big right triangle AMP over side TM of the small right triangle TMB equals to side AP of the big right triangle AMP over side TB of the small right triangle TMB, and it is also equals to side MP of the big right triangle AMP over side MB of the small right triangle TMB. AM is 3 over TM. TM is the missing side, so it is. And it is equals to AP. AP is 6 over TB. TB is the missing side, so leave it as it is. And it is equals to MP. MP is 3 over square root of 5 over MB. MB, what is the left of MB? MB is AB. That is 6, because it is one side of square ABCP. Minus AM, that is 3. 6 minus 3 is 3, so MB equals to 3. So in total, we found out that 3 over TM equals to 6 over TB, and it equals to 3 times square root of 5 over 3. We have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and we left only with square root of 5. We have here those two sides are equal to each other, that is to say 3 over TM equals to the square root of 5. 3 over TM equals to the square root of 5. We multiply this equation by TM, and then we divide it by square root of 5 simultaneously, and finally found out that TM equals to 3 over square root of 5 units in its length. This is side TM, that is equals to 3 over square root of 5 units in its length. Those two sides are also equal to each other, that is to say 6 over TB equals to the square root of 5. 6 over TB equals to the square root of 5. Here we multiply this equation by TB, and then we divide it by square root of 5 simultaneously, and finally found out that TB equals to 6 over square root of 5 units in its length. This is side TB, that is equal to 6 times square root of 5 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? The area of the green shape equals to the area of the big square TSQP minus the area of this quadrangle MBCP. This is equals to 27 square meters inside according to what is given as the question, minus the area of this small right triangle TBM. Repeat again, the area of this green shape in total equals to the area of the big square TSQP minus the area of quadrilateral MBPC. This is equal to 27 square units in inside according to what is the last question, minus the area of the small right triangle TBM. The area of the big right triangle, the area of the big square TSQP. The area of any square equals to the length of one side squared. And again, the area of any square equals to the length of one side squared. Therefore, the area of this square TSQP will be equal to the length of side TP squared. And again, the area of this square TSQP equals to TP squared. And again, the area of the big square TSQP equals to the length of one side squared, that is TP squared, minus the area of this quadrilateral MBCP is equal to 27 square units inside according to what is given in the question. So the area of quadrilateral MBPC equals to 27 square units inside, minus the area of this small right triangle TBM. The area of the right triangle TBM equals to the base TB times the ITM over 2. Is equals to the base TB times the ITM over 2. TP equals to TM plus MP. Again, TP equals to TM plus MP, therefore TP squared equals to TM plus MP squared minus 27. TB equals to 6 times square root of 5, and TM equals to 3 or square root of 5 units in itself. And again, TB equals to 6 times square root of 5, and TM equals to 3 or square root of 5. And we have to divide it by 2. Divide it by 2 here. Tm equals to 3 over square root of 5. MP equals to 3 times square root of 5. And we have to square it. Minus 27. 6 times 3 is 18. 18 over 2 is 9. So in total, in the numerator, we have left only with 9. And square root of 5 times square root of 5 is 5. So in the numerator, we have only 5. We have here square root of 5. 3 over square root of 5 plus 3 times square root of 5. Here we multiply this number by square root of 5 and then we divide it by square root of 5 in order to have a common factor with this number. And we have square root of 5 times square root of 5 is 5. 5 times 3 is 15. So in total in the numerator we have 15. In the numerator we have square root of 5. So we have a common factor of square root of 5 with those two expressions. And we have here 3 plus 15 squared minus 27, and 9 fifths is minus 9 fifths is minus 1.8. 3 plus 15 is 18. So we have 18 squared over square root of 5 squared minus 27 minus 1.8. 18 squared is 324, and square root of 5 squared is 5. So in total, this expression equals to 324 over 5 minus 27 minus 1.8. We have in total 324 over 5 is 64.8. So in total, we left only with 64.8. Minus 27 minus 1.8. 64.8 minus 1.8 is 63, and 63 minus 27 is 36. So in total, we should know that the area that we are looking for this question, that is the area of this green shape, equals to 36 square units in its size. Okay, thank you very much.